Hi everybody, thank you for joining us today. My name is Doug Welker from Hartwig, and joined today by some of our partners from Okuma America, and we are going to talk about the topic du jour in the manufacturing industry, regardless of what actual industry segment you're part of. It's automation. Now I know I don't have to tell you why automation is such a hot topic. You know, as everybody's coming back to work now finally, we are starting to see shops wanting to do a lot more with less. And so we have an LB3000 here that we're going to talk about, the Okuma Armroid Robotics System that can tend to the lathe, as well as an overhead gantry loading system. We're going to talk about some other things too, but those are the main things we're going to hit on. And hopefully you can see why this technology is a game changer for your shop to make you more competitive. Now please use that Q&A box that you see below to ask any questions during the presentation. At the end of the presentation, we're going to be joined by Okuma's Wade Anderson and David Fisher, and they'll answer any questions you might have. Thank you guys, and enjoy the show.
Welcome to Okuma America. I'm Tim Thiessen, Vice President of Sales and Marketing. Today I have with me Chris Davala from our Applications Engineering Group. And we're going to review the Armroid, a form of automation from Okuma, with you today. And we'll be doing that. It's on the LB3000. It's our flagship 2-axis lathe. Chris, let's get started. The first thing I noticed when I walked up to this machine is with automation, I usually expect to see a fence around the machine.
Sure, absolutely. Typically you would have a third-party integrator that would do all your automation for you. So a third party that would come set up your robot, set up your safety fence, all those sort of things. Because this is an Okuma built and manufactured robot, we don't have a need for that. So in this case, we have our Stocker, which lives right in front of the machine. So between the Stocker and the robot that's inside the machine tool, everything's enclosed in one nice, tight, compact little environment. So we don't have the need for all that additional wasted space by having a safety fence.
Yeah, and that's got to save in some installation time, cost, and other things. I also notice when things are fenced out like that a lot of times there's coolant and chips on the floor. This looks like a pretty neat compact system.
Absolutely, because we're never really taking the part outside of the machine environment with the robot. There's no chips falling out of the machine, there's no coolant dripping on the floor. All of it stays contained inside this nice little package. So this is our 4-pitch Stocker, we call it. So you can open the door right there. You see we have 4 different levels of our Stocker. You can see maybe we have an 1.5 inch or so diameter shaft. So we'll probably fit about 6 or 7 of those on each shelf. The robot will grab them off the one shelf, load them into the machine. After it's done, it'll put them on the finished parts shelf. We have some sensors to let the robot know when the shelf is either empty or full.
Well, it looks a whole lot better than having a parts catcher hanging off the front of the machine.
Absolutely. Your parts aren't getting dropped on each other. They're not banging into each other when they get dumped in the bucket. You know, it allows a nice smooth transition of part unloading where you don't want your high value parts just banging against each other sometimes.
Now, having said that, it's a fairly big unit. Can I see you move it into position?
Absolutely. So literally 2 fingers. You can slide this guy over. Has some nice rollers on the bottom. Once it's in position, we want to make sure it stays locked in position.
Great. Well, let's take a look inside the machine.
Slide it right back open, and that's how hard it is.
So what are the main components of the Armroid in the machine?
So inside the machine, we have the robot, which lives in the machine tool all the time. Typically, you would see a robot that's outside the machine tool. This is basically the first of its kind, where the robot is in the environment all the time. Okuma manufactures and builds those robots, so we control the entire process start to finish. And in the back, we also have a drawer that will slide out that has some different end effectors, which are the end pieces that go on the robot.
Okay, so I have more than just the one set of grippers that's in the Armroid.
Sure, so we have a set of grippers, and we also have a few different accessories depending on what your process is that might be beneficial for you.
Can we take a look at those?
Absolutely. So 1 M code allows the drawer to open, 1 M code allows the drawer to shut. Once it's open, we can open this and take a look.
Okay, so it's like a storage cabinet, and I see 3 positions, and I'm assuming the one position is already in the Armroid.
That's right.
And it's a gripper. So what are these other 2?
So the one you see on the right here is a coolant nozzle.
Okay.
So we can use that coolant nozzle to spray at our tool. So the robot will swing around to this side, opposite of our cutting tool. So we can use that for chip control during the cutting process itself. We can also program the robot to move that nozzle around and wash down the inside of our machine tool. So chip control is a very big part of automation. We have to make sure we have chips under control all the time. So if we're not worried about chips on the workpiece itself, we're worried about them on our cutting tool, worried about it getting packed up inside of our enclosure somewhere. So this allows us to program a path to wash down the environment inside to keep chips under control.
Yep. Now the other one looks like either a steady rest or a steady roller. What is that?
Sure, so that's a roller that we can use as a work support.
Okay.
In some cases with a long, slender shaft, you would want to have a steady rest. In this case, we don't have provisions to mount that, but because this is dedicated for shaft work, we know that we might have shafts that are unfavorable length to diameter ratios, things like that, that we need some extra support. So we can use the robot while it's not busy changing parts to help support our workpiece and make a better quality part.
So it's really a lot more than just a robot loading and unloading
Absolutely.
parts.
If you only want to have the gripper, you can certainly do that, but you also have the option to have some other accessories as well. This particular Armroid is for shaft work only. We also have another type of Armroid that's for chucker work. So that gripper would be more of like a 3-jaw chuck where you would load parts that would just get put in the chuck, not so much a shaft. A little bit different style conveyor where instead of having 4 shelves, we would have more of a lift-up style conveyor like we would on our OGL series. So a few different options, to suit just about anything you need.
That's great. Well, I guess the next big question when it comes to automation is how you program it.
Sure.
And that always is challenging, right? Because somebody's got to be able to program a machine, and now they maybe have to learn a new language for the robot. So
absolutely.
I hear this one's pretty easy to program. Can you tell me a little bit about it?
Yeah, it sure is. So just like you would create some NC programs, right? Here we have our NC program. Here we have our robot program creation. We just tell it we want a new file. And basically you have a menu that walks you through the entire process. So do you want to unload parts, load parts? Do you want to do a part flip, work support, wash down, all those things are just a simple menu. Then you just work from the top down, put in some variables, and it guides you through the process.
Yeah, kind of like a conversation.
Absolutely.
Conversational, yeah. So in addition to creating the program, it also kind of appears that it's able to avoid crashes and stuff too, right?
Sure, absolutely. So our collision avoidance system has been around for many years, standard on some of our higher tech products. In this case, you have a high dollar robot that you don't want to have anything happen to. So we use our collision avoidance to monitor the robot motion and everything inside. So in this case, we're giving it some commands on what we want it to do, but the actual robot motion path will be automatically generated for you.
Okay.
So there'll be some points that we teach depending on what size stocker we have. So we'll teach some load and unload points inside the stocker, and also some load and unload points for the work holding in the chuck. And other than that, the actual motion path will be created. You mentioned somebody needs to know how to program a machine tool, then they now need to program a robot as well. So that takes some of the guesswork and some of that added pressure off the operator.
Okay. So if Okuma's making the machine and the robot, then it knows the solid model of the turret,
Absolutely.
the spindle, the robot. I just have to input my unique information about my work holding or tailstock.
Just like our standard collision avoidance, you would input your work holding. Are we going to use the tailstock or not? What is our workpiece size and length? Any tooling that you mount to the turret, things like that. The machine tool itself, we already know where all those components live, so we can protect you at all times. So just to show you how truly compact this system is, right here you have the robot controller that handles all the motion control for the Armroid, and it fits right inside of our standard electrical cabinet, so there's no accessories outside the footprint of the actual standard machine.
Well, we appreciate you taking the time to join us for this representation of the Armroid, and we look forward to our next video, right, Standroid?
Absolutely.
All right, thanks for joining us.
Hope you all found that information valuable on the Armroid system on the LB3000 there, and the Okuma team is actually working very hard to adapt that Armroid system to other turning centers. So look for more information on that coming soon. So while we're still talking LBs and automation, we're going to shift now and we're going to talk about the overhead gantry loader system.
My name is Ken Bouchel. I'm one of the regional managers for Okuma.
And my name is Chris Davala. I'm a principal engineer in the applications engineering department here at Okuma.
Okay, today we're going to talk about the LB3000 EXII Mark II. What we have mounted to it is an OGL10 gantry loader designed and built by Okuma. The LB3000 is really our flagship product. It's the #1 quoted machine we have in our lineup. It comes in multiple configurations as far as bed lengths, as far as end function, Y and W. This particular machine has MYW. We have almost 10,000 LB3000s worldwide installed in the field. I'd like Chris to talk about some of the features of the OGL10.
Absolutely. So as Ken mentioned, this is an OGL 10. So the 10 stands for 10 kilograms of weight capacity. We have 5 different variations of this, so we can go anywhere from a 5 kg to 150 kg. So basically from 11 pounds to 330 pounds. We can mount this to our smallest LB3000 lathe or our largest LB45 lathe. So there's a wide variety of equipment that will suit your automation needs. This particular one has a 20-station stocker table. They also come in a 10 and a 6, so depending on the volume of parts that you need to take care of, we have something that fits just about every application. These are engineered solutions, so basically every one is custom fit to your application and your needs. Inside the machine, we have a swivel hand. We can use chucker work or shaft work, so depending on what kind of parts that you have, and multiple variations of the swivel to accommodate whatever you need.
Hey Chris, what about programming the machine?
Programming is actually quite easy. So this particular machine, we use G&M code programming, so it's basically just point to point. So instead of a PLC like a lot of robotic stuff would have, or automation things would have, it's very simple G&M code, so you can easily teach your points, understand your program. It's all done through an integrated teach pendant on the machine tool, so you don't have a third-party integration of any kind. No separate robot controller, everything is done right from the OSP control, so it makes it very user-friendly. Speaking of the LB series lathe, how do you think customers feel about this machine? What's their favorite aspect of this machine?
I would say the favorite aspect is the accuracy of the machine. This is a very thermally stable platform. It's built on a very unique box slant bed design. It makes it extremely thermally stable, minimizing operator intervention and offsets throughout the day. Okuma's thermal-friendly concept is based on several principles. Chris, can you talk about those principles?
Sure, that's a great point. The thermal-friendly concept for Okuma means we have a bunch of sensors mounted inside the spindle and the casting. We understand and can predict very accurately how the machine will grow throughout the day based on ambient temperature. So what we do is we make minute adjustments in the background that the operator never needs to see. So instead of him having to chase offsets when the temperature changes throughout the day, the machine does that for you and it minimizes the operator intervention. So in an automated cell like this, that's very critical because you don't want to be chasing offsets all over the place. So it makes it very user-friendly for the operator. So some of the other features of this machine that lend themselves well to automation are things like an automatic touch setter. So when you're running production unattended, you want to check on your tools, make sure you don't have any tools that are broken. Maybe you need to make minute offset adjustments. We can use the touch setter for things like that. We could also mount the spindle probe to the turret. So if we wanted to do any checking in process, your workpiece size, we have the ability to do that. If you don't want to check in process, we can add a third-party piece of automation to do part measurement outside in the cell. So you can still have your operator keep track of all your part sizes without having to be here all the time. Other things we can do are things like tool load monitoring and tool life monitoring with redundant tooling. So anytime you want to run automation, you want to make sure that you have a very solid process, good chip control, keep on top of your tooling, all without an operator having to babysit this thing.
Okay, this concludes the discussion on the LB3000 EX Mark II and Okuma OGL Gantry Loader. Thank you.
Guys, thank you very much for watching the presentation here, and I hope you guys find that information valuable, and it shows how this can change the game for your shop, adding these automation capabilities to your Okuma lathe. And with that said, we are going to turn it over now to the Q&A portion of this, live Q&A, and we have Okuma's Wade Anderson and David Fisher on the line here, and they can answer any questions you might have. Thank you for watching.
Yep, loud and clear.
Hey, that's a pretty good video, even though I know we're the ones that did it, but I enjoyed that.
I did too. What happened to the last time? Did you break the camera? They didn't let you back on?
Right.
Yeah.
No, I think it was great. One of the questions that came in was the stockers on the LB with the OGL. Looked like the stocker was on the left-hand side. Can you put a stocker on the right-hand side too, or are they only on the left-hand side?
You can. So, Greg, what we do, we typically bring those machines in and we inventory a certain amount of those. So we package them up as a kit. So we bring them in as a kit with the stalker on the left side, and it's a certain amount of feed tables. Yeah, 20 stations. So that's one kit that we bring in, we stock, but we can offer that basically as an engineered solution as well. So we could extend the beam on the other side, put a stalker on the other side. We could also incorporate value-added features. So if you needed gauging, part washing, things like that, those are engineered solutions that we could look into as well.
When we go to the right side mounted stalker, then you have to go to a rear exit chip conveyor.
Oh, good point.
Yeah.
Yeah, good point. Thanks, David. You know, the Armroid's really interesting. I think it's a pretty cool concept. The first one like that, frankly, I've ever seen. Really curious how the programming works and if there are limitations to the programming, because it's done through the OSP control.
Right.
So can you guys speak to that?
Yeah. To me, it's one of the coolest pieces of technology that we offer right now. A lot of work and a lot of thought went into this. So one, you need to think about it in terms of the market that it's meant to serve. So the Armroid is really meant to address the issue that a lot of customers bring up where they say, hey, we need to put another spindle on the floor. We need another machine. We need more production, but I can't find the right guy to actually operate the machine for me. So the Armroid is really meant to address that vacancy in the marketplace. So you bring in a machine that comes already with the operator for it. So it is limited to a certain extent as compared to a typical robot where you would teach it, teach points and things like that. But the most amazing piece of the Armroid and our Standroid for that matter is it uses a Navi automation system or programming system. So it basically teaches itself the motion path to get in and out of the machine. So again, addressing the fact that a machine shop owner doesn't have to have a robot programmer on staff to be able to operate that. There's a conversational window on the OSP control where you teach it where you want to pick up on the part, because you may have a off balance weight, things like that. So you teach it a position where you want to grab the part, and then you teach it where you want to load and unload from your stalker. And then after that, the control figures out, it looks at collision avoidance software, and it determines what is in the way, and it creates its own motion path to get in and out. So really amazing technology from that standpoint. Is there anything you want to add?
And I mean, rather than having a control for the robot and a control for the machine, everything, including the pulse handle. So if you need to move the robot around, you use the machine's pulse handle. Everything is on the OSP control. So it just makes it easy for the operator, because they learn the OSP control. They deal with the machine, they deal with the robot. I mean, everything's very familiar to them.
Yeah, I like the point too that it's one throat to choke, so you don't have to call multiple people to work on the robot or integrate a robot or whatever it is. And Okuma, Hartwig, Gosger, Morris, we can work on these even though we haven't seen them yet. We will be able to work on them in the future when we see these out in the field.
Greg, you're a plane flight away, my man. We've got two. I've got one right here on my floor in Partners and Think on the Maltus, which is a really cool, very slick looking piece. And then we've got the one that was in the video over across the street at OAC in the aerospace showroom.
Yeah. Another question just came in. You showcased the OGL. How many options does it come in? I'm guessing that could be, it may be in part weight or length, speed. I don't know. But it also comes on other machines as well, maybe in a different name, like a 2SP machine. But David or Wade, would you guys mind mentioning different options for the OGL?
Right. So I'll start with basically addressing the type of machines. We can virtually do it on any machine that we bring in. We can offer an OGL on. They're very popular on the LU series as well as Maltuses. We've got a lot of systems in the field with our Maltus, our multifunction platform, with rows of Maltuses all tied together with a gantry loader. So we can do the OGLs on a lot of different platforms. And then the weight, it really varies, and you can probably talk to that more than me, but it's based on the weight of the part. It's the series of OGL that we would pick for the type of work that you're doing.
Right. So the OGL 10 is basically a 10 kilogram arm, right? So it's weight based. So you could do a 5 kilogram part in each gripper basically. We go up to an OGL 150. So you can do some pretty heavy parts, and even to maximize, you know, that weight, we quite often, when we go up to that size, we're typically doing a single gripper. So that's the weight of, you know, max weight of one part, could be up to that 150 kilograms. And that's usually going to be on like our LB Mark III series, you know, our big turning longer bed. But there's a wide range. And then of course our 2SPH series use the we call the F-type loader. So it's a facing loader for the facing spindles, right? And those go down to OGL3, OGL5. So again, a 3 kilogram, 5 kilogram arm. But typically the number is the weight in kilograms on the loader arm.
Okay. And I can't tell who asked that question. It's an anonymous one. So if we didn't answer that question, whoever asked it, please let us know. We want to be able to answer your question correctly. Another question, Armroid is very cool. Since the Armroid is designed for shaft work, do you expect you might add this to a grinder in the future?
Really good question. I think that remains to be seen on the market adoption for that type of technology. Currently, we offer them on the lathes only, so the lathes and the Maltus for the Armroid. And then let me clarify, there's two different series of our automation that we're bringing in from OCJ. One's called the Armroid, and that is a robot that's built by Okuma that is inside the machine enclosure. So when the machine comes in, the Armroid is part of the machine, just like a tailstock or a turret is part of the machine. The other one we offer is called a Standroid, and we just got our first one in. We've got it at the Aerospace Center, and that is a Okuma design kitted up package, but it is an external robot for milling machines. So we can offer the Standroid on lathes, but traditionally most of, I think, the applications we'll see for that product will be on mills, where we're coming in the side, like an M560 for an example. We can mount a Standroid beside it and then pass the parts in and out. And the same programming software, this Navi software that we utilize, is available as what programs the robot on the Standroid as well. So again, it's perfect for the job shop that doesn't have a robot programmer. You've got a system that you teach it some load points through a conversational window, and then it programs its own motion path in and out of the machine from that point.
Cool, thank you. Next question, and it looks like the last one at this point. Armroid has what weight capacity?
There's actually two different ones. So the one we have on the LB is a 5 kilogram arm, and then the one we have on the Maltus is a 10 kilogram arm. Now the 10 kilogram unit is available for the LB as well. So the LB has a choice of either a 5 or a 10 kilogram arm. On the Maltus, the only one available is the 10 kilogram arm.
All right, another one just came in. Would you be able to have a gripper to part off with on the Armroid?
It's a good question. I don't know the answer to that yet. I think that's something we're gonna have to look at. So the system, and I know it talked about it in the video, but the system comes with a roller support, a coolant wash nozzle, and then the actual gripper. So whether it's a shaft or a 3-jaw chuck type system, that would come based on the type of Armroid that you're buying. But I don't know that we've actually looked into whether or not we could modify, one of the end effectors to actually be a part off catcher, if you will. So yeah, we'll look into that.
Yeah, there might be some interference issues there. I don't know. Let's see. That might be it. Yeah, I think. Yep, that's it. That's it, guys.
Very cool.
Yeah. There's another one just came in the chat. So what is the max shaft / part length and diameter the Armroid can load on the LB3000?
So anytime you ask a question that's like high level,
pass it to Dave.
The answer's still a little deeper. I looked to my guy to the right.
Well, this is one of our applications, guys, so you're in good company.
All right.
So Mark's max workpiece length is 440 millimeters.
Okay.
So 17-ish inches, whatever. And then max diameter, we actually offer 4 different stockers. One is for chucking work, and then 3 different ones for shaft type work. So it depends on the stocker, but it can be 50 to 80 millimeters in diameter.
Okay.
I think you'd have to balance that based
And,
on weight. as
Right,
well.
and the chucking size, as far as that stocker, is 150 millimeters long and 150 millimeters diameter. So 6 by 6, basically.
Okay. This is it. Okay, another one. It's good they keep rolling in. When using the Armroid, does the auto door open and close every time?
Yes.
Yes.
That basically keeps the coolant chips out of the material stocker.
Yep. Yep. Yeah, okay. Standroid. Okay, another one on Standroid. What's the max length and weight on the Standroid product?
I don't
That
know
I
if I've
do
got
not
that.
know. Yeah, that's been mostly on the machining center side, although it is available in the lathe, but I haven't tapped into that yet.
Yeah.
I would assume it's similar to what the flange size, the stacker capabilities are on the lathe as far as diameter, but I better just leave it at that and get back.
Yeah, let me pull some information on that, and I can get that to you, Greg.
Yeah, a lot of good questions, guys. A lot of this is new to us, as you can tell. New technology and stuff. Some of the information we have from OCJ, some of it we don't, but we can tell you we're all excited about this automation, where this is going, the technology, and Okuma's really driving technology here, and it's very nice to see. So with that, I'm going to go ahead and say thank you. We kept it under 30 minutes. Thanks to all the folks that jumped on today. Thanks to Wade and Dave and all the folks at Okuma that helped put the video together. It was great, and we got more to come. So thank you all, and look forward to seeing you guys all again soon.
All right. Thanks,
All right.
guys.
Bye-bye.